To truly understand the map of the world, we cannot start on the crust. We must travel to the exact mathematical center of the planet. For centuries, cartographers visualized the Earth using surface-level drawings, much like the map stretched across this vintage wooden globe. However, true geography relies on a rigorous system of coordinate geometry radiating outward from the molten core. Our objective is to construct that global grid from first principles. Once we build the mathematical scaffolding, we will track one specific, highly tested vector, the Tropic of Cancer, or the 23.5-degree north line, across the globe, zooming all the way down to a microscopic regional scale. Visible geopolitical borders only make sense when you understand the invisible geometry beneath them. That underlying geometry dictates everything from climate zones to national boundaries. This diagram showing a cross-section of the Earth allows us to redefine what a latitude actually is. It is an angle, not an arbitrary surface drawing. By measuring an angle from the core upwards relative to the equator, projecting that point onto the surface and spinning it horizontally, we draw a full circle. That circle connects points of identical angular distance from the center. Counting these angles gives us a precise mathematical limit. We project 90 distinct angles toward the North Pole and another 90 angles toward the South Pole. Add in the 0-degree equator itself, and the Earth holds exactly 181 latitudinal angles. There is a mathematical discrepancy between these 181 discrete angles and the grids we use. Despite having 181 angular measurements, the physical globe only contains 179 actual latitudinal lines. The reason lies at the absolute extremes of the planet. At exactly 90 degrees north, there is no horizontal space to rotate that angle into a circle. The measurement projects onto the surface as a singular, infinite dot rather than a ring, a geometry mirrored at 90 degrees south. The math resolves perfectly. We take the 181 total latitudinal angles, subtract the 2 polar points because they cannot form circles, and we are left with exactly 179 latitudinal lines. The flat maps we memorize in school stretch and distort these dots into straight lines. They are two-dimensional compromises forced by absolute three-dimensional spherical limits. Looking at this rotating projection, we can observe the mathematical constant of the latitudinal system. Because the angles are evenly spaced from the core, the physical surface distance between any two adjacent latitudinal lines is always exactly 111 kilometers. The physical, spatial area trapped between these two parallel lines has a specific geographic term. It is called a zone, or in Hindi, a Kuttaband. While latitudes form full horizontal circles, the system requires a vertical countermeasure. Longitudes are semicircles drawn vertically, dropping directly from the North Pole down to the South Pole. The space trapped between two vertical longitudes is defined as a Gore. When we overlay the horizontal Kuttaband zones with the vertical gores, the intersection creates the global grid. This intersecting grid is the mathematical scaffolding of the planet. Every act of global navigation and every geopolitical boundary drawn throughout history relies on these exact coordinates. This diagram isolates one highly specific mathematical vector, the 23.5-degree north line. Commonly known as the Tropic of Cancer, this line marks the northernmost latitude where the sun can appear directly overhead. Tracing its path on a flattened projection reveals its macro-geographic footprint. This single vector slices cleanly through exactly 3 continents and 17 different countries. Starting in North America, the line intersects just 3 nations. It passes through the United States via the Hawaiian Islands, cuts across Mexico, and finally runs through the Bahamas, anchoring this theoretical geometry in physical streetscapes like this one. Crossing the Atlantic, the vector enters Africa. Here, it spans 6 separate nations, dragging a straight line from Western Sahara in the west all the way through to the ancient architecture of Egypt in the east. The line then enters Asia, its densest continental segment. It pierces 8 countries, beginning in Saudi Arabia and terminating its continental journey in the dense urban environments of Taiwan. Along this vector, we find massive geographic extremes. The line crosses China, representing the largest national landmass on the Tropic of Cancer, contrasting sharply with Taiwan, which represents both the smallest country and the shortest intersection point. If we measure the raw length of the intersection, the record falls to India. The Indian subcontinent hosts the longest continuous stretch of the 23.5-degree north line of any country on Earth. Among all 17 nations, the national capital sitting closest to this global mathematical vector is Muscat, the coastal capital of Oman. The Tropic of Cancer is a continuous geometric vector. It physically ties disparate global cultures, geographic extremes, and diverse climates to the same solar angle. Zooming in on this high-contrast map of India, we can track the exact path of the 23.5-degree vector. Moving west to east, it cuts horizontally across 8 specific states: Gujarat, Rajasthan, Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura, and Mizoram. At the state level, the scale extremes mirror the global ones. Rajasthan represents the largest total landmass intersected by the line, while the far eastern state of Mizoram is the smallest. When we measure the continuous length of the line inside these borders, Madhya Pradesh contains the longest stretch, while Mizoram contains the shortest. The vector also reveals a demographic anomaly. Out of all 8 states on this mathematical line, West Bengal, captured here in Kolkata, holds both the highest total population and the highest population density. Just as Muscat was the closest national capital, the state capital situated closest to the Tropic of Cancer in India is Agartala, located in Tripura. We perform a final microscopic spatial zoom into Rajasthan, home to architectural landmarks like the Hawa Mahal. Looking at the state borders, the vector barely grazes the southern tip, passing through exactly 2 districts, Banswara and Dungarpur. These global geographic constants dictate local realities. The climate, sunlight, and precise position of these 2 districts are anchored by the exact same mathematics that define the entire planet. As we pull back from that single patch of desert in Rajasthan, rushing out through the atmosphere and back into the void of space, the scale of the system becomes clear. No location is isolated. The 2 districts of Banswara and Dungarpur share a direct mathematical linkage to the deserts of Africa and the islands of the Bahamas, all pinned to the exact same 23.5-degree angle. The full latitudinal circles, the vertical semicircles, the 111-kilometer zones, and the intersecting gores, these are the tools we use to convert wild, arbitrary space into a rigorously predictable system. The borders and dotted lines we see on flat maps are merely shadows. The true geography of our world is a strict, calculable coordinate geometry, radiating constantly outward from the molten center of the Earth.